In this lesson, we're going to talk about the sum of different sequences. So you can see on the top of your notes, you have the arithmetic and geometric sequence. And what it means to be a sum, it is to the right. Let me see, I might be off a page here. There we go. So the series is an indicated sum of the terms of the sequence. You can fill that in. And an arithmetic sequence. So here's ones that we've talked about. Arithmetic, where we're adding the same amount. So we're adding 3 each time. When they want the sum of these numbers, they want to take each term and add them together. And that's when we're looking for the sum. Same with geometric. You can see in this one down here we're timesing each term by 3. But what they're looking for is they want to add all these up when we're doing the geometric series. So a sequence is the list of numbers. The series is when you're adding them together. So we have two different ways that we can do that, and we're going to practice both ways. The first one is called the sum formula. So to use the sum formula, it's saying the sum of so many terms, and then this looks a lot like variables we've learned before. That's our term number, that's our first term, and then that's our final term there. And then if you look at the one below that, or to the right, I'm sorry, let's go to geometric. Same idea. The sum here, we have our common ratio, our term number, our A1, and then our common ratio here again. So that would be if you want to use the sum formula. The other way you can use is sigma notation, and this is normally the preferred way that students use, but it does require you to remember a little bit on your calculator. So if you forget something on your calculator, you can always go back to the sum formula and use that formula, and that will work every time without having to know a spot on your calculator. Just to alleviate some fears here, these formulas will be given to you for your test, so you do not have to have these memorized. These are ones that you will be given, and you can just know when to use them. The sigma notation, if this symbol is one you haven't seen before, this means to add, or the sum. And so that's our sigma notation. And then on the bottom you put your first term to be added. So that's normally, in our case, n equals 1, because we start with the first term. Not always, though. You will see in a word problem that we do, we sometimes start with like the third term or some other term. So it's not always a 1, but we tend to start with our first term. And then whatever our last term would be at. So if they say find the first 15 terms, this would be a 15 up here. And then this looks very similar, doesn't it? That's what we use for our arithmetic sequences, and the same with our geometric. You've seen that before for our explicit formulas. So, to actually start going with these, it says find the 30th term, or the 30th sum for this series. So we want to add the first 30 numbers. Now I realize you could list all 30 of these out, because you probably have already recognized that this is adding by 2. And you could write all 30 out, and you could list them. That would not give you any credit on this, because we were trying to find ways to not have to do it all out. So our formula we're going to use for this one to start is our sum formula. And this is arithmetic, so you'd have to recognize that these numbers are changing by 2's. Notice that there's plus signs between these because they're giving us a series, not a sequence. So they will put the plus signs in for us. So we want to find the 30th term. We'd say the 30th term, the sum of the 30th term is, and then my n value in this problem would be 30 times a1, well my first term is 2, plus an, which means what is the value of my 30th term? That's what needs to go right here. I don't know my 30th term, that's not listed here, so I'm going to have to go off to the side and try to figure that out using what we've learned in previous days. So I would say I'm going to use this formula right there. That's my explicit formula for arithmetic sequences. And again, these are given to you on your test. And I'm going to say, okay, I need to find my 30th term. So I'm going to find the 30th term. I take the first term plus the 30 minus 1, because n is 30. And my common difference is a 2. So here I would say my 30th term would be 2 plus 29 times 2. 29 times 2 is 58. So my 30th term is 60. Now that I've found that, I'm going to plug that in here. Oops, not a 30, how about? My 30th term is 60, so I'll put that right here. And again, I found that by actually having to go calculate that. They did not give me that. I had to know to look for it. And then I continue with my formula over here. This is all divided by 2. So if I add all 30 terms together, so 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16, and we keep going all the way to 60, right? When I add those all up, I would take 2 plus 60, so 62 times 30, and then I divide that answer by 2. And when you plug that in, you should get 930. And this is how you would do that using the sum formula. Now to use the sigma notation, I'm going to show you. You'll see at the bottom of your notes right now you have a different problem and it shows you that. I'm going to show you how to do this on your calculator. And so what we're going to do for sigma is we have the sigma symbol, right? And then we want to know the first term we add. So our n is 1 and we're going through 30 terms. So now on my calculator that I have on my smartboard here does not have the update. And so that can be kind of a problem, right? So I'm going to show you how to do it. I'm going to tell you what buttons to push so you get the screen that looks like this. So what you should push is you should go math, and then when you go to math, you go down to the 0. So at the 0, you should see it'll say error, and then it says summation, and then it has the sigma symbol, and then it has a parenthesis. That's what you want to be on. So hit enter on that, and then you'll see this screen right here. You'll have this and that. That's what's on your screen right now. And you can see that it's blinking right here. So here's where you put the X, which if you forget where the X is, it's right there. So that red button there, that's your X. And again, I can't show you on here because the calculator doesn't have the update. So if you're confused by this when we're all done, watch through it twice, make sure you know how to do it. If not, you can let me know tomorrow and I'll show you how to do it on your calculator. So then when I do that, I'm going to go X, and then we're going to plug the 1 in. So you'll go X, and then it goes straight to the 1. It just automatically, you don't have to hit anything else after the X. So I put a 1, I push 1. Now you see it has a right arrow button, so arrow to the right, and it flashes up here. And here we'll put a 30 because we know we're looking for the 30th. Now over here, in this part now, it wants to have, if you look at our formula, it wants a1 plus n minus 1 times d. So what we're going to have to do is reduce this equation in red here, and that's what goes in this little box. So my a1 value, if you don't remember, is 2 plus n. We're going to leave it in n. It doesn't want to know what's the 30th. That's what this is for. You leave that in n minus 1, and then our d happened to be 2. So we simplify this like we learned with our arithmetic sequences. Arithmetic explicit formula. So I have 2 plus 2n minus 2. So when I simplify this all the way down, I get 2n, which is what I'll put in this box in my calculator. So and we know we're using x, right? Hopefully you realize that. So I put in 2x there. Let me make that an x so it's not confusing. 2x. If you wanted to use the alpha key and use an n, that would work. I just think x is faster. And then I arrow over and I hit enter. I should get 930. Same answer no matter which formula I use. So we'll practice with both today. If you don't have the update on your calculator or you have an 83, the formula listed at the bottom of your notes on this first page here, so this one, well, that's not giving you the formula. I don't know if it's on here. Let me check quick. Yep, right here. This formula here is what you will enter. So it has it spelled out exactly the buttons you push. It's a little more work to remember this, right? Because there's a lot of buttons to push. So if you don't have the update or you have an 83, you might want to just learn the sum formula because that will be easier for you. If you have the update or on the 84 or the newer 84s, that one we just did together will be really good too. So, and if you need help with this, try this one out for the problem we just did. So remember we had the summation of n equals 1, and then we had a 30, and then we had 2n here. If you don't get 930, you come show me that tomorrow and I'll help you with whatever's going on with your calculator. So now, it says right the first 50 positive odd integers. So we have to come up with this sequence ourselves. So think of odd integers, that'd be like 1, 3, 5, 7, right? Odd integers. So that's my series, or my sequence. Now it wants me to do the series. So we're going to go ahead and use sigma here. And I'm going to say we want to add with our first term, and it asks for how many? The first 50. So we're going to do 50 numbers that we're going to add together. And so I'm going to punch this into my calculator. But first I have to, for this spot, I have to say that that's going to be a1 plus n minus 1 times d. So let's figure that out for this problem. a1 would be 1, right? Plus, we always leave this n minus 1, and our common difference here, we're adding 2 every time. So when I go ahead and distribute here, I would have 1 plus 2n minus 2. So I have 2n minus 1, which is what's going to go in this spot right here on my calculator. So you can use your calculator and put this part in, and when you hit enter, so go ahead and do that for a minute. I'll show the formula we should use there. When you hit enter, you should get an answer of 2,500. That's the answer I have in my key. Let me double check that with my calculator. So I'm going to go over and do math 0, summation. I've got x1, I'm going to 50, and then I put in that 2x minus 1, and when I hit enter, I got 2,500. So hopefully that's what you got also. If you did this using the sum formula, you should get the same answer. So either way, same answer. Number 3, it says find the first term of a geometric series. This is our first one, geometric. You'll see we have the formula right here, for which the sum of the first 8 terms is 765. And the common ratio r is 2. So let's plug in what we know. We know that S8, right, is 765. So I'm going to put that in here. Equals A1. Do we know A1? They don't give us A1, so we're going to call that A1. Times 1 minus r. R is 2 raised to the, oops, I don't want the parentheses yet. I got to put that exponent in there. They just told us it was the 8th term, right? Isn't that our n value? So we're going to say to the 8th, and then over 1 minus r. So here, if I start to simplify this, I have 765 equals A1 times, and I would take 2 to the 8th, and then I take 1 minus that number. So I'd get negative 255 over negative 1. So now I'm going to solve this equation for the first term, because that's what they had us looking for, right? I mean, we should have known that was our variable, because they said find the first term. That's A1. So now when I do this, I'm going to times both sides by negative 1 to get that out of the denominator. So I would have negative 765 equals the first term times negative 255. And then as I simplify this, I'm going to divide both sides by negative 255. And I end up with my first term being 3. So there's my answer for number 3. My first term is 3. And you could have used either formula here if you wanted to use the summation one. I think that this sum formula was easier than the sigma notation, but it's your choice. So now it says find the sum of this series. Use the sum formula and the sigma formula. So we're going to do it both ways. This one, if you look at our series, see how they didn't put the signs right next to it? Hopefully you'll realize that's a negative 6 and a negative 54. So I'm going to recognize that this is not an arithmetic series, but it's going to be a geometric because I'm timesing by negative 3 all the way through here. So right now I know I'm using geometric, and here's my two formulas I use. So my A1, I'm looking for S of n, but how many are we adding? Let's see, the sum. Here is my last term. I don't know what term number that is though, so I don't know how many numbers I'm adding, which means I don't know my Sn. So I need to find out which, this is my value of An, my nth term, that's the value of it. I don't know the value of n though, so the first thing I'm going to do is find n. So I'm just going to put that right in the middle here. Find n, because I don't know that here. In order to find n, I use this formula here for geometric. We did that yesterday. So I know the value of my nth term is 118,098. I know A1 is 2. I know my common ratio is negative 3. And I don't know n. So here I'm going to divide both sides by 2. And I would get 59,045 equals negative 3 to the n minus 1. Here's my problem. I want to take a log to both sides, and I can't. Why can't I take a log to both sides? See, my Houston, we have a problem. I can't have a negative log. So I can't take a log to both sides. So I need to pray, maybe, that this has a common base of 3. So I'm going to take negative 3. Let's just pick a number. I'll take negative 3 to the 5th power. When I take negative 3 to the 5th power, I get negative 243. And I want a number that's going to be 59,000, so I better go a lot higher, right? Like negative 3 to the 15th power. Well, negative 3 to the 15th power is a really big number. So I got to go somewhere in the middle here. Let's just pick 10. Negative 3 to the 10th power. Ooh, winner, winner. Look at that. And I got lucky here. I'm just estimating. It is trial and error. I have no idea that 3 to the 10th power is 59,000. As a math teacher, I don't have those numbers memorized. So I had to use my calculator to help me kind of estimate. Notice how I started with 5. I thought that was really low, right? So I went really high to 15. Well, that was way too big. Split the difference. I got lucky. But if it would have been 3 to the 9th, I'd have been close. I would have just kept trying till I found it. So now I know that negative 3 to the 10th power equals 59,045. So then I can leave this as negative 3 to the n minus 1. Since my bases are the same, I can set my exponents equal, so I get n to be 11. Luckily, I know that common base rule, otherwise I wouldn't be able to solve this problem because I can't use logs. So now that I know n is 11, I'm finding the sum of 11 terms. So here I'd say the sum of 11 terms, A1 for this problem was 2 times 1 minus the common difference, or common ratio, excuse me, is negative 3. So 1 minus a negative 3 to the 11th. Notice how I wrote that. That matters there. So I have to take the negative 3 to the 11th before I take the 1 minus that. And then divide it by 1 minus a negative 3. So as I keep simplifying here, I would have 2 times 1 minus, and when I take negative 3 to the 11th, I get negative 177 and 147 over 4. I keep simplifying this, the sum of the 11 terms. I'd have 1, boom, boom here, right? I'd have 177,148 times by 2, divide by 4, and I can do all this on my calculator. I get 88,574. Now, the other way I could do, so this is my sum formula. The other way I could do this is my sigma notation, and I should get the same answer either way. They both work the same. So here, if I'm doing the sigma, I have the summation. My first term to be added would be n equals 1. And since I found my n, I know I'm going to 11 terms. So that's my last term to be added. And then I plug it into this formula right here. A1, we just said was 2. My common ratio is negative 3. And then I leave it n minus 1. We know n is 11, but remember that's why this 11 is here. So using my calculator, I'm going to go ahead and punch that in and put it exactly like this. Make sure you put parentheses around this negative 3, raise it to the n minus 1, and you should get 88,574. Same answer either way. And I want you to be able to do it both ways. So now we have another one that I want you guys to try. So I'd like you to do number 5, and I'm going to show you both the sum and sigma. You choose which one you want to do. I'm going to show you both. So pause the video, start number 5, and then I'll start working on it after you unpause it. So in 5 we have a geometric sequence again, or series, excuse me, and our first term we're given. The nth term is 6, and the common ratio is negative 1/6. So if I start to plug that in, I don't know. Well, let's just start plugging in. Let's say I'm going to use the sum formula. So if I use the sum, I would say the sum of, well, I have no idea, right? I don't know my n value. So again, we're going to have to go in and find that n value, just like we did in the last problem. So to find n, I say an equals a1 times r to the n minus 1, same as the last problem. My an, it tells me my an is 6. They actually call it nth term is 6. They tell us that. So I'm going to go 6 equals a1. My first term is 7,776. My ratio is negative 1/6, and I have that to the n minus 1. So I'm going to divide by 7,706, and I'm going to get 1 over 1296. Now I put this in fraction form. You maybe have a decimal. And I have that equaling negative 1/6 to the n minus 1. I can try and make this a common base, or I can use, I can't use logs, it's negative. So I have to find a common base. So 1/6 to some power is 1 over 1296. So I'm just going to pick negative 1/6 on my calculator, and I'm going to raise it to the, let's say, 5th power. Let's just try it. So negative, I'm going to move this down here so I can show some work here for you. Negative 1/6 to the 5th power is, as a fraction, negative 1 over 7776. And that's not what I'm looking for. I'm looking for 1 over 1296. So let's try a smaller one, like negative 1/6 to the 3rd power. If I do negative 1/6 to the 3rd power, I get negative 1 over 216. So that's too small, right? I'm going to guess it's negative 1/6 to the 4th power, because it seems like my answer should be in the middle there. When I plug that in my calculator, so negative 1/6 to the 4th power, I get 1 over 1296. So I found it now. 4 is my key. So here, I'm going to erase this work here so we have more room for this. I know that negative 1/6 to the 4th power is the same as 1 over 1296. Negative 1/6 to the n minus 1. So see how I have common bases now? They're both negative 1/6. So I would say 4 equals n minus 1. And when I add 1 to both sides, I now have an n of 5. So I'm going to go up to my work now, and I know my n is 5. So I can use that now for the rest of my problem. Whether you did sum notation, or sum formula, or sigma notation, you should get the same answer. So I'll show you both of them. In the sum, you'd have the sum of 5 equals a1 times 1 minus negative 1/6 to the 5th. Oops, I need that 5 in there, sorry. Over 1 minus a negative 1/6. So when you plug that in your calculator, negative 1/6 to the 5th, and then 1 minus that, times 7,776, you should have gotten the sum of the first 5 terms to be 6,666. If you did sigma, you would have on your calculator done this. I'd say n equals 1. I'm going to 5. A1 is 776 to the negative 1/6 to the n minus 1. And again, you should get 6,666. So the same answer either way. Those can be kind of confusing, but remember, you don't have to show me both ways, just one or the other. So you can choose which way you do. I gave you both, blue and red. You have to have one or the other, not both. The last couple we're doing are from your Excel math, so you're going to want to pay close attention to these. And this says write as a sum of terms. So they want you to actually give all the values when you plug these in. So the first term you'd plug in is a 4, and you're going to plug in a 4, a 5, a 6, a 7, and then the last term's an 8. So we're going to show the value for all of those. So all you have to do is plug all those numbers in for j and then show that as a sum. What I mean by that is I take this right here, and where the j is, I'm going to put my first term, so 4. And then I'm going to do a 5. And I'm going to go through and substitute all numbers up through 8. 6, 7, and 8. And I knew what to put in there because I was looking at my starting point was a 4. That's why the 4 went in first right here. And it went all the way to 8. So that's why I went all the way through 8. So from here, you just have to simplify this. 4 squared is 16. 16 times 2 is 32. 32 minus 3 is 29. So there's how I write it. You may do all that on your calculator. So check to make sure you get the same answers. But when I plugged the 5 in, I got a 47. When I plugged in the 6, I got 69. When I plugged in the 7, I got 95. And when I plugged in the 8, I got 125. You don't have to add these. The answer is they asked for writing it as a sum. They don't actually want the answer. That'd be easier if you want the answer. You just plug that in your calculator, the original problem. That's what they're looking for there. So you're just going to substitute the values they give you. And this is our first example of where we had a starting point other than 1. So that's kind of interesting to look at. The last one we're going to do. This one, it says write in summation notation, and they give it to us. So what we're going to do first is we're going to work these backwards, because we won't ever have to do any of these without having multiple choice. So we're going to work with them from front to back. And so the first thing we're going to do, we're going to plug in this value right here, whatever they give us. So the 1, the 0, the 1, and the 0. And we'll see if we get the first term. So here's our first term. When we plug them into each of these, we should get our first term. So when I plug in a 1 in for x, or in for n here, I have x to the first over 1 plus 2. So I have x to the first over 3. That's not my first term, so this one's out right away. When I plug in a 0, I would have negative 1 times x to the 0 plus 1 over 0 plus 5. So I have negative 1 x to the first over 5. That is my first term. Now that doesn't mean I'm done, because I have to check and make sure none of the other ones work. When I go to C, I'm plugging in 1 for n. That's where it's going, in those n spots. Negative x to the 1 plus 1 over 1 plus 5. I already can see I'm getting a 6 here. That's not going to check. My last one here, I'm going to plug in a 0. So I have negative x to the 0 plus 1 over 0 plus 5. I have negative x to the first, and that checks. So B and D so far work. When I have two that work, I have to go to the next term. The next term in this series would be n equals 1. And if I plug in n equals 1, I should get this value now. So when I plug in n equals 1 here, I'd have, I'm just going to go ahead and erase this red so you guys can see a little better. And hopefully you wrote that down, or else you can rewind to copy if you need to. I have n equals 1, so I'd have negative 1 to the x to the 1 plus 1 over 1 plus 5. Negative 1 to the x squared, and that's just x squared over 6. Now this one says a positive, and I have a negative here, and no matter what I do, this is going to be negative, so I think this one's out. Let's check D, though, to make sure it works. This would be negative x to the 1 plus 1 over 1 plus 5. Negative x squared over 6 is x squared, right? Negative x times negative x would be positive x squared. So this checks, so D is my answer. So you'll be working backwards on all of those. And hopefully that makes sense to you. Make sure if you're doing your accelerated math and you have questions on that, you let me know.